guys, this is my third and final video for our rotational apparatus. All right, so this is a little bit about your data table and what you should be looking for. Here I've set it up with the masses. Again, I've started with the smallest mass possible, 0.12 kilograms. Below that, my apparatus didn't move. I've got my radius, because remember, that's the radius that we're applying the force perpendicular to cause rotation. Here's my distance and my times. You can see I have a very long time at the beginning, getting a little more rapid. It's a little hard to tell from this time that it's spinning really rapidly at the end. From this, I can calculate my accelerations in meters per second squared. And of course, as the amount of force goes up, then we've got force going up, so you get more acceleration. You can calculate the radians per second squared. You don't need to do that, but you should put it in your data table so you get used to using the bridging formula. And in my data table, I have uncertainties. Now, these are my uncertainties. You need to think very carefully about what your uncertainties are. And then, of course, I'm going to calculate and put in my experimental moment of inertia based on all of this data. And you have to do that by deriving your own formula. I definitely haven't shown you the formula. The calculations for all this should come down here. And so I should be able to follow all of your steps and have an understanding of what you did. Be careful about what you need to square and not square down here. So let's take a look at these values that I have. I've got 0.043 and 0.039 for these first two. I haven't given you the calculations for all of those, but what you're starting to see is that I'm going to probably have an average around 0.04. And I just want to remind you that from earlier, I had calculated a theoretical moment of inertia back on the very first page of 0.0202. So I am almost 100% slower. I have about double the moment of inertia than what I thought. And so I'm going to have a lot of things to write about. What else is contributing to my moment of inertia? All right, that's it. Hopefully, given these three, that you can get this lab done. Remember, this is a major lab. I'm looking for good graphs. I'm looking for you to answer all of the questions, and so go very carefully. The lab will be due a week from tomorrow, next Friday. You'll have all day Monday. It's a 90-minute period to collect really careful data and work with your neighbors. Also, you could probably create your graphs then. And then on Wednesday, we're actually going to talk about rotational kinematics, the difference between slipping and rolling objects. And on Friday, I will give you little review activities because next week, we are going to take our unit test on rotation and then move on to waves, our second to last topic in AP. Hope that helps and look forward to seeing you next week. Bye now.